This is a client machine which has a blank folder. So inside this blank folder, a file named sample.txt is created, which has 12 MB of size, which contains some data like hello world, which also has a equivalent binary saved in it, right? So let's understand from the sync file sync perspective. So a service named file sync is also running inside that client machine. And let's recap what we discussed so far. So file sync service is also observing any changes to that folder. When I say changes, I'm talking about any file creation, modification, delete, and so on and so forth. So a file is created named sample.txt inside that folder, which has 12 MB of size, which contains some binary data in it. So as soon as a file is created, file sync service acts upon it. Let's understand what exactly file sync service is doing here. So a file sync service is connected to the cloud, which sync any modification to that folder back to the cloud, right? So whenever you make any modification to that folder, file sync service replicate those changes back to the cloud. There is another machine also exists named client machine B, which also gets a modification and has a similar folder replicated in it. So this folder is also replicated to client machine, and whenever client machine B also make any modification to that folder, when I say modification, I'm talking in terms of any modification in the files in that folder, that also sync back to the cloud. And once that syncing is done to the cloud, that also sync back to the client machine. So it happens vice versa. Any modification to that folder done by client machine, that also replicated back to the client machine B, and whenever a modification done to the client machine B, that also replicate back to the client machine. So now let's discuss about what's happening inside client's machine. So this is a watcher service which is constantly watching any changes detected inside the folder. When I say change detection, I'm talking about any new file creation, deletion, updation, and so on and so forth. This is the first step. So when a change is detected by a watcher service tells sync bit service, hey, there's a change detected inside that folder. So further sync bit service talks to the chunker service in the third step, and chunker service further in the fourth step chunks the data in smaller pieces. So we can see that we have chunks data in four pieces, and we can also see that the sample.txt has 12 MB of size, and we have divided the complete chunk of data in 4 MB of 4 different chunks. Further, chunker service gets that chunking data and send it to the sync bit service in the fifth step. And further sync bit service actually connects to the blob storage in the sixth step and saves a copy of this sample.txt in blob storage. So sync bit service further talk to the meta service in the seventh step, and meta service receives the chunk bits, right, along with the metadata. So meta service in the eighth step talks to the local meta store, as well as in the ninth step it talks to the cloud meta store, where it actually saves the copy of the metadata of the received chunks. Metadata service plays a very important role here. So the complete architecture is used to design Google Drive or the Dropbox. My name is Piyush, and this is what we'll discuss in today's discussion. So now let's go back to our client machine, and let me just recap what we have discussed so that we can connect the dots and we can deep dive more into the components which we have discussed earlier. So client machine has a folder, blank folder inside it, and in that blank folder we are creating a file, maybe with the name sample.txt, which has 12 MB of size, which contains some data, maybe a text data, hello world, and which has equivalent binary, right? So there's another file sync service running inside the client machine, which is constantly observing any change in that folder. When I say any change, I'm talking about creating, deleting, or updating any file, right? So we, as soon as we create any file or we make any changes to existing file, this file sync service acts upon it, and when it acts, it actually connects to the cloud and create a replica of that folder inside that cloud, right? Whereas there is another machine, client machine B exists, which also gets a copy of that folder which was created in client machine. So client machine B also sync up whatever changes client machine is doing in that folder, right? Whenever a client machine B also make a change to that folder, that change sync back to the client machine through the cloud storage as well. So now let's deep dive into file sync service. So the client machine talks to the blob storage and saves a copy of the file created inside the folder. In fact, this is the file service which talks to the blob storage. Let's go deeper in the file sync service and understand what's inside it. So file sync service contains two services, the sync bit service and the meta service. In fact, this is not the file sync service which is saving data to the blob storage. It is sync bits service which is saving blob data to the blob storage. What exactly the meta service is doing now? So the meta service is getting the chunk details and saving it to the cloud meta store. Why exactly we are saving the data to cloud meta store? This is what we'll discuss later. So meta service also keeps a copy of the metadata of the chunk data to the local meta store. Why do we save that data to the local meta store? This is how we understand that in case there is any change detected in a file. So we compare the existing saved chunk with the newly calculated chunk. So in whatever chunk we see there's a change, we only update that piece of chunk to the blob storage and the local meta store, so that we understand that this is the piece where the change is detected. Instead of saving the complete file every time whenever there is a change detected to the blob storage, we actually update the chunk where we detect the change. So we discussed about the changes. How do we get this a file change? This is the watcher service which tells us that hey, there's a change detected in the file. So watcher service continuously watches or monitor the folder. If there is any change detected, watcher service tells the other components that you need to perform your actions. So how do we chunk the data? This is the chunker service. Whenever there is a chunk detected through some other components like sync bits service and watcher service, chunker gets the command to chunk the data in bits and pieces, and then it further send those chunks to the underlying component or services like sync bit service and meta service. So there is another service which is notification service, and that's where the cloud meta store comes into the picture. So whenever there's a change detected in cloud meta store, for example, we make any changes in the file. So we understand which chunk is updated, because we also save a copy of the chunks in cloud meta store. We only update that updated chunk to the cloud meta store. So whenever there's a change detected in cloud meta store, the notification service detects that change, and it sends notification to the other machines, so that they can also sync the latest changes saved to the blob storage. And that's where the cloud meta store and notification service comes into the picture. So from the sequence perspective, that's how the sequence or workflow looks like, and that's how the other each and every components talk to each other. Watcher service constantly watches the changes inside the folder. Whenever there's a file change detected, watcher service talks to the sync bit service. Sync bit service further asks chunker service to chunk the data and gets that chunk data back to the sync bit service. Sync bit service further compare the chunk with the existing saved chunk. If there is any change detected in the chunk, that chunk is actually updated to the blob storage. Instead of saving or updating the complete file, we only update the updated chunk in the blob storage. And then the chunk is also sent to the meta service, so that we meta service also update that chunk to the meta store as well as in cloud meta store. So in case we update any chunk detail in the cloud meta store, that's what notification observe and detect. And notification service then further send notification to the other client machines like client machine B to ask them to take a latest copy or update of the file from the blob storage. That's how the flow looks like. And if we go a bit deeper and we save these details in the storage, that's how the complete picture look like, and that's how the local metastore, cloud metastore, and blob storage looks like. So we can simply see the file is saved in blob storage in 4 chunks, because the file size is 12 MB, and we chunk that 12 MB of size in 4 MB each, with the name 001, 002, 003, and 004. That's what we can also see inside blob storage. In case there is a change detected in chunk 001, that is the only chunk will be updated in blob storage. Likewise, in meta service, we also save the SHA-256 calculation for every chunk, and that's what we compare and detect if there is any update in any chunk. Meta service keeps a local copy of the file, and whenever there is change detected, we calculate the chunk again and compare the newly created chunk with the existing saved chunk. If there is any mismatch in chunk, that means there is a update in that particular chunk, and meta service update that chunk to the local meta store, as well as it update that chunk detail to the cloud meta store. So whenever there's a update detected inside cloud meta store by notification service sends a notification to other machines, so that other machines can also update the local copy of file from the latest file from the blob storage. That's how the complete flow looks like. So now let's deep dive into the component implementation. and let's understand how each and every component is implemented and working. So before I discuss about the component implementation, let me give you a gist of how the complete discussion will take place. So the complete discussion is divided into two parts. In first part, we'll discuss about when a newly file is created inside folder and how exactly the service would react in that case, because there would be no blob stored in blob storage, as well as there would not be any kind of data saved in local metastore as well as in cloud metastore. Maximum implementation part we'll discuss in the part 1. In the part 2, so because in part 1 we have already discussed about when a new file is created, there would be a file available in blob store as well as in the metastore. So whenever we make a change, again we'll calculate the chunks, and we'll compare the newly created chunk with the existing chunks saved in local metastore. When there's a chunk mismatch, that means we have to update that chunk in blob storage, as well as we have to update that chunk in local metastore as well, along with the cloud metastore. And in the second part as well, we'll discuss on the notification service, how exactly notification service would work in that case. So let's look what's happening inside the watcher service. So watcher service is constantly watching insert, update, delete events happening on the directory. I might be repeating some of the information which we have already discussed just to maintain the parity, and it will be easier to understand the complete workflow. So we have a blank folder, and inside the blank folder, we are creating some sample.txt file having 12 MB of size with some binary bits inside it, right? So watcher service is constantly watching any event happening to that directory. So let's look what's happening inside the watcher service. There's a method written start watching, which expects a directory path which watcher service has to constantly watch for, right? Let's look what's happening inside the watcher start watching method. So the code I am referring right now is the code written just for reference. So you can write the code in whatever language you want to write, and just see this code as a reference only. So this code is divided into two parts. Maybe the part which has written above while loop, where we are initializing what events we have to look for, and we are initializing those events in the upper portion of the while loop. And when we go deeper and see the while loop, inside while loop, we can see that the watcher service is waiting for an event to occur. And once the event happens, what's happening is watcher service is actually calling sync bits service with the file path where the event has occurred, right? So that's how watcher service watches any event happening on the directory, and once it detects any kind of event happens, it actually calls the sync page service for further processing. So this is what is happening inside watcher service. Watcher service constantly watching any changes detected to the directory it's been asked for. And let's move ahead and understand what's happening inside the second step when watcher service is calling sync page, and what we are doing inside sync page when we call a sync page method. So this is the first step where watcher service is calling sync bit service, the sync bit method of the sync bit service, right? So watcher service is providing a file path to the sync bits method of sync bit service, and this is the file path where the change has been detected, right? So when the sync bit service receives the call from the watcher service with the file path, it further calls the chunker service with the file path where the change has been detected for the further processing. So far we have discussed about the watcher service calling syncbit service. Now let's understand the step 3 where syncbit service calling chunker service. So once the request is received from watcher service to syncbit service, then further syncbit service will call the chunker service and pass on the file path where the change has been detected. So chunker service will read that file and split that file into smaller chunks. So far what we have discussed is that watcher service is constantly watching any changes detected to the directory it was asked for. In case there is any change detected to that particular directory, watcher service picks up that file path where the change has been detected and passes on that path to the syncbit service for further processing. And syncbit service passes on that particular path to the chunker service to chunk the data. And this is what is happening inside the fourth step. Chunker service starts chunking data to that particular file path where the change has been detected by the watcher service. So let's look how exactly the method looks like in chunker service. So syncbit service is calling chunk file method and passing on the file path where the change has been detected. So now let's understand what's written inside the chunk file method. So chunk file method is receiving a file path where the change has been detected. So further chunk file method will start chunking the data saved inside that particular file. So here we have written some line of code which I'll not discuss in detail. Instead, I'll just discuss the piece of code where critical logic has been written to chunk the file. So let's understand what's happening inside this main piece of code. So we have defined a chunk size to create a chunk of the file of 4 MB. So you can define the chunk size whatever you want, maybe 1 MB or 2 MB or I mean it's up to you. So take this code as a reference only, and you can write your own code to split up the file, right? So this is the main piece where we are performing some of the actions, like we are chunking the data, we are hashing that particular chunk, we are also calculating the block ID string, and as well as we are adding these calculations in the list of chunks. So we are creating an object of chunk and then adding that object of chunk in the list of chunks. Why I'm discussing these three, 4 lines in detail is because these calculations are very critical to understand this system design. And going on, maximum part of the discussion would be around these calculations only. So these calculations are a bit critical to understand this system design. So now let's understand what's happening inside the while loop. In the very first conditional statement, we can see that we are reading input stream and we are always picking up 4 MB of data and initializing bytes read, right? So bytes read will always tell you how much data is there inside buffer, right? For example, we have 16 MB of data available in the file, and we are creating a chunk of 4 MB, right? At the last iteration in the while loop, bytes read will only represent 2 MB of data, right? And in the buffer there would be 4 MB of data. So in the very first line where we are initializing chunk data, what would happen is we'll only get the 2 MB of data at the last iteration. That's what we are doing in the first line inside while loop. We are filtering out any extra added data in the last iteration. So let's look inside what's happening in the first line where we are initializing chunk data, right? So if you look closely to this file, right? So I have added some of the binary just for reference. And because we are chunking this file in 4 MB of data, the complete binary can be divided into 4 MB of chunks, right? For example, this first iteration can create this chunk of data, right? And once this while loop will run, from the first line inside this while loop will return this chunk of data. So now let's understand what's happening next. So we are calling compute SHA-256 method to compute the hash of the chunk. So let's look inside the implementation of this compute SHA-256 method. So this code written in Java language, and you can take a reference from this code and you can write the code in the language you want. So we are passing this chunk data to the compute SHA-256 method, and through the implementation of this method, we are actually calculating this particular string, right? Which is nothing but the SHA-256 hashing of the passed on data. So this is the passed on data, and this is the SHA-256 calculation of this particular passed on data. Once the calculation is done, we returned this SHA-256 hashing back to the while loop and initialize the chunk hash with this string. So now let's understand what's happening inside the next line of code. So string.format actually taking the block ID of integer, of type integer, and then converting that particular integer to 6 digit of numbers and adding trailing zeros if required, right? So once the conversion is done, the string.format is converting that particular number to block ID string in a string format. So let's see what's happening. So this is the block ID initialized with 0. In the first iteration, it will be 0, right? And the code percentile 06D will convert that particular 0 into 6 times of 0. So at some of the places I have used 001, and at some of the places I have used 6 times of 0. So please do not get confused from this. So once this is calculated, the string block ID str will be initialized with 6 times of 0. Once all the values are calculated, now let's understand what's happening inside the next line of code. So we are creating an object of chunk with the value chunk ID string, chunk data, chunk hash, and bytes read, creating an object of chunk and then saving that particular object in the list of chunks. So once the first set of data will be saved to the list of chunks, this is how the data, combined data would look like. And this table is created just for the reference. So let me fast forward the video and fill the remaining data in the table. So now let's fill the size for these blocks. So once the table has been filled with the chunk data, that means once the chunking is done, all the chunk object has been created, added to the chunks list. The chunker service further send that list of chunk back to the sync service. So let's recap what has happened between sync service and the chunker service. So sync service passes on the file path where the change has been detected to the chunker service. Chunker service reads that particular file, create a list of chunks and send it back to the sync service for the further processing. So this is what we have discussed so far. So step number 1 till step number 5. So what happens next is SyncBit service actually talks to the meta service and asks meta service that if there is any existing chunk for that particular file or not. Why exactly SyncBit service asking meta service to check whether there is any existing chunk available for that particular file or not? This is what we'll discuss next. So SyncBit service is actually asking meta service uh, that there is any existing metadata available for that particular file or not. And meta service actually fires a query to the local meta store and check if there is any existing data or not. So because we are understanding the scenario where a new file is created, so there's no data available in the local meta store. And when meta service queries the local meta store, there's no data available. That's why the local meta store is blank right now. So let's understand from the coding perspective. So let's zoom in and understand how SyncBit service is talking to the meta service. So SyncBit service is calling get chunks for file and making a call to the meta service. So there's a typo and I have mentioned file ID, just ignore it. So SyncBit service is calling meta service and asking if there is any existing chunk available or not. And then meta service is actually making a call to the local meta store where it is checking whether there's any existing chunk available for that particular file or not. So there's no chunk available in the local meta store. And that's how the SyncBit service, including this call, that's how the code inside SyncBit service would look like when we add this method call. And this is the flow we have discussed so far. So let's understand what's happening next, which is what will leads us to the step number 6, where we actually compare the existing calculated chunk with the newly calculated chunk. Why are we doing this? So this is where the meta service comes into the picture. For example, the file. Uh, so, for example, if the file is already saved inside the blob storage, right? So as the file metadata would also be saved inside the local metastore, right? Since we have already discussed, in case we detect any change in the file, we only update the updated chunk to the blob storage instead of the complete file. That's why we calculate the chunks of the file where the change has been detected, and then we compare those newly calculated chunk with the existing saved chunk. And that's how we identify the chunk where the change has been done. So once we detect that particular change, instead of saving complete file to the blob storage, we actually update that particular updated chunk to the blob storage, as well as we update that particular chunk to the local metastore. And that's where this condition comes into the picture. When we compare existing saved chunk in the local metastore with the newly calculated chunk, and if the condition is false, that means we have identified the chunk where the change has been done, and then we save that particular chunk to the local metastore, as well as we save that chunk or update that chunk to the blob storage instead of saving the complete file. This is what happens in the step number 6. SyncBit service save the chunks to the blob storage. When I say chunk, I'm talking about the bits and pieces of the file where the change has been detected, right? In this scenario, since we are creating a new file, since there is no existing chunks available inside the local metastore, that means uh, the condition would be false for every newly calculated chunk, and we'll save those chunks one by one to the blob storage, and the file will be created inside the blob storage. Let's understand from the coding perspective. In this highlighted line, we can see that we are asking metadata service just to send us if there is any existing chunks available. Since we are creating a new file, there won't be any chunks available, right, for that particular file. So this if condition is false because there is no existing data available inside the local metastore, and then we move on to the else part. So we move on to the else part. When a new file is altogether is created, that means there is no existing chunk data available inside the local metastore. And in the second scenario, where the change will be detected in case there's a pre-existing calculated data available in local metastore, that means there's a change detected in existing file, right? So here we are discussing the scenario where the new file is altogether is created. In that case, the if statement will be false. So if we closely look at the else statement, we see after the print statement, we have three major line of code written. In the first line, we see that we are saving that particular chunk to the blob storage. Um, and after that, we have written two further lines where we are calling meta service to save that particular chunk to the local meta store. And after that, we are saving that particular chunk to the cloud meta store as well. So the first line, this is what is the step number 6, and further we have written two lines. Those lines are the step number 8 and 9, which we will discuss after the discussion of the step number 6. Let's focus on the step number 6 when we save that particular chunk to the storage account, right? So these are the binaries of that particular file, and these are the pre-calculated data which we have already discussed. So just to add one more detail here, so I'm using blob client here, which is created of Azure's blob storage service. So I mean, you can just take a reference from this code and you can use the services you want, and you can use the cloud storage as per your convenient. So this is the chunking data which we have already calculated, and we check whether there is a change detected inside this chunking data or not. Since we are creating a new file, so the statement would be false, and then we will land to this line of code where we'll save that particular data to the storage account. I'll not discuss the complete for loop and the iteration of the list of chunk. Instead, I'll discuss the process, and I'll not go deeper to discuss each and every iteration, right? So this is the data, the 4 MB of data, and we have chunked the 12 MB of data in 4 MB of data, right? Let's go ahead. These are the numbers, maybe the chunk IDs. So at some of the places I have written 0000, 6 times of 0. At some of the places it is 001. So please pardon me for that, because these are a lot of data. So sometimes I just uh, lose the track of the things. So this is the blob storage. Where sync service actually save that particular chunk. And this is nothing but the step number 6. At every iteration, we save that chunk one by one based on the if statement. If a change is detected, then we save that particular chunk to the blob storage. If a new file is created, then every chunk will be saved to the blob storage in the step number 6. So now let's move back to the block diagram, and let's recap what we have discussed so far for the better understanding. So watch a service constantly watching the folder if there is a new file created or there is an update in the existing file. So in our case, a new file is created, and once the watcher gets that detail is actually passed on to the sync service. For the sync service, calls to the chunker service and pass on the file path where the change has been detected or a new file has been created. And then further, chunker starts the chunking of the data for the path has been passed on to the chunker service. It chunks the data, and then after chunking is done, that chunking data is actually passed on to the sync service. Further, based on the then further sync service actually talks to the meta service and check whether it's a new file created or is there any update in the existing file. That means when we match the newly created chunk with the existing chunks, based on that particular condition, we actually talks to the blob storage. If a new file is created, the replica of file is created to the blob storage. That means we save each and every calculated chunk to the blob storage. In our case, this is what is happening right now. Once the file is saved inside the blob storage, further sync service talks to the meta service, pass on to those particular chunks to the meta service for the further processing on the local meta store and the cloud meta store. Next, meta service talks to the local meta store storage, and since we are creating a new file here, meta service actually save that chunking detail to the local meta store. And this is what we'll discuss in the step number 8, saving chunks to the local meta store using meta service. So let's go back to the for loop again, and let's focus on the else statement, because we are creating a new file, and every time we'll iterate uh, the every object of new chunks will land to the else statement. So now I'll discuss on the method calls save chunk and the save chunk to the metadata. So these two method calls are the calls we are making to the meta service. So in the step number 7, we'll call the meta service, right? Please do not get confused, because in the step number 7, I have actually combined both of the calls, the save chunk and save chunk to metadata. So please do not get confused that in a seventh call how exactly we are making two calls. So it is a combined representation of save chunk and save chunk to metadata. And then in the eighth step, save chunk will be covered, and in the ninth step, save chunk to metadata will be covered. So going forward, I'll not discuss each and every iteration of the chunk object. Uh, just to save some time, I'll be discussing about how exactly the list of chunk look like in a tabular format, which we have already discussed while we were discussing the step number 7. Likewise, I'll discuss the save chunk and save chunk to metadata. So complete table will be saved in a single go to the local meta store. Just think from the loop perspective that we'll be reading the chunk one by one from the new chunks list, and the operation will be done one by one. The saving will be done one by one per chunk to the local meta store as well as to the cloud meta store. So now let's focus on the step number 7, where sync bit service is calling the meta service, and sync bit service is calling save chunk and save chunk to metadata. Although we'll be discussing the step number 8, and in step number 8 we'll be discussing the save chunk method. And this is the complete descriptive diagram, and we can see the step number 7 there. So now let's understand what's happening inside this step number 7. So likewise, this is the segregation of the sample.txt file, and this is what the chunker has sent to the sync bit service. It's a list of the chunks, new chunks, right? We are iterating the list of chunks one by one and sending that particular and sending each object of new chunks to the meta service to save that particular chunk to the local meta store. Again, this is the segregation of the file, and then once the segregation is done in the 7th step, we are passing on those details to the save chunk. Now let's understand what's happening inside the step number 8. So this is the list of chunk, I mean the tabular representation of the new chunks, which is the list of chunks, right? Which the chunker service has passed on to the sync bits. And this is the meta service, and we are actually passing this list of we are actually iterating we are actually iterating each object of new chunks and passing on that particular chunk to the meta service. And then meta service at the end of the for loop will actually save each and every chunk to the local meta store. And this is what is happening inside the step number 8, where sync bit service is iterating the every object of the new chunks list sent by the watcher, and then sending each and every chunk to the meta service. It is calling save chunk method, and save chunk method, meta service is saving each and every chunk to the local meta store. So now let's move on to the component level architecture. So far we have discussed that meta service in the 8th step, meta service is saving the chunks detail to the local meta store. In the 9th step, the meta service will also save these chunks details to the cloud meta store. And once the data is saved, this is how the cloud meta store would look like. The operation is quite similar to what we have discussed in the local meta store, and uh, while saving these chunk details to the cloud meta store, which is nothing but the 9th step, uh, we call the save chunk to metadata method of the meta service. So the sync bit service calls the save chunk to metadata method of the meta service to save these details to the cloud meta store, which is this method. And we have to remember 2 3 points here is that if you see this method closely, you would see that we are adding some extra details like the file and device ID. Let's look at the data saved inside the cloud meta store. As I said, we are seeing two extra columns, file and the completed sync details. These details will discuss and come into the picture when we'll discuss on the notification service. And that's how the data in the cloud meta store would look like once the details are saved, or once the chunks are saved one by one inside the cloud meta store. And that's how the detailed high level architecture would look like. So now let's move back to the component level architecture once again, and let's recap what we have discussed. So we have discussed the scenario where a new file was created, and that's what we have already discussed, that the complete architecture or the system design will be divided into two parts. The first part will cover when the new file will be created, and in the second file, the newly file, which we'll discuss in the first part, will update that particular file and we'll see the update scenario. So, in the first part, what we have discussed is that a new file was created inside the folder which watcher was constantly looking for. Any changes being made to that particular folder where watcher is constantly watching. So watcher then send that particular file path to the sync bits, and then sync bits ask chunker to chunk that particular file. So chunker chunks that particular file and send that file, send the chunking detail back to the sync bits. Since the new file was created, there was no existing local meta store was available for that particular file, as well as there was no data available in the cloud meta store as well as in the blob storage. So sync bit service actually save those chunks detail to the blob storage, as well as it asks meta service to save those chunks detail to the local meta store as well as to the cloud meta store. So sync bit service iterate the calculated chunks or the list of chunks which was sent by the chunker to the sync bits. We iterate as we have already discussed. That is a if condition where we check if there is any existing chunk details available for that particular file. Since we discussed that the file was newly created, there was no existing data available. So sync bit service send those chunks detail one by one to the meta service, and then meta service save those details to the local meta store, and then sync bit service also save those chunks one by one to the blob storage. So this complete workflow covers the scenario where the file was created from the scratch. In the next section of this video, we'll discuss about the second part where this file, the existing file, will be updated, and we'll cover the update scenario. Not only that update scenario, we'll also cover the notification service where the file and device ID will come into the picture, which we did not discuss while discussing the step number 9, because we also saved two more details, file and the device ID. What is the significance of those two details saved inside Cloud Meta? So this is what we'll also discuss in the second part. So far we have covered the part 1 of the video where we have discussed the scenario where the new file was created, right? Uh, when the new file is created, there is no data present in local metastore, blob storage, and the cloud metastore. Since we have discussed about the if statement where we compare the existing saved chunks detail in the local metastore, since the file was newly created, there was no data present, and we iterated the chunk list provided by chunker to the sync bits, and then each and every chunk was uploaded to the blob storage, local metastore, and the cloud metastore, because there was no chunk detail present in the local metastore because the file was newly created. That's what we have covered in the part 1 of the video. In the second part, since the file is already uploaded, we'll cover the scenario that existing file will be updated so as a new chunk, so as the any existing chunk of that file will get changed, right? Since the data of that particular file is already present in the local metastore, the newly created chunk will have some of the chunks where there would be a mismatch, uh, there would be a mismatch of the chunk with the existing saved chunk in the local metastore. Once we identify that particular chunk where the chunk details have been updated, we only figure out those chunks and upload those chunks to the blob storage, as well as we update that chunk detail in the local metastore and the cloud metastore. This is what we'll discuss in the second phase of this video. Instead of uploading the complete file, we identify the chunk where the chunk has been updated, and then we perform the required actions. And this is what we'll discuss next. So now let's go ahead and understand the change in existing file scenario. So this is the file we have been referring so far, and this is the initial text was written to that particular file. So let's go ahead and make a change in any of the word. So I'm updating small w to capital W. I'll also change the color of that particular word just for the readability. So we have changed the small w to capital W. This is the previous binary of that particular string. So this binary is just for reference, is not the actual binary conversion of the text written in this sample.txt. So just take a reference from this binary, that's it. Let's go ahead and understand how would watcher behave in that case. So once there is any change detected to the file, the watcher would behave the same we have discussed earlier, right? So let's understand what's changing inside this file. So the binary 1 1 will be changed to the binary 0 0, and that's how the new binary would look like. So once there is a change detected, watcher service will again uh, detect the changes to the file and send that file path to the sync bit service, and sync bit service will further pass on that particular path to the chunker service. The step number 1, 2, 3, and 4 are same, which we have already discussed. So now let's move ahead and understand how exactly the chunker would chunk the data. So if you look closely, we can see that there is a binary change in the sample.txt, and the block ID 001 has been changed. The binary of that block ID 001 is changed 11200, and the calculated SHA 256 is also changed. The change has been highlighted with the red color characters. And this is the list of new chunks by the chunker service, and chunker service will create a list of the chunks of that particular file where the change has been detected, and the chunker will send this list of chunks back to the sync bit service. And that's what is the fifth step, where the chunker service will create the list of chunks and then send those and then send that particular list of chunks to the sync bit service. So now let's move on and discuss on the fetch local existing metadata of that particular file where the change has been detected. So the sync bit service will further talk to the meta service and will call this get chunk for file method, and the meta service will get that file path, and maybe the file ID can be the file name. There's a typo, so please make changes as per your convenience, right? So further, sync bit service will make a call to the get chunk for file, and then uh, uh, the meta service will connect to the local meta store and will fire a query to get the pre-existing chunk details of that particular file. And once the existing chunk the list of existing chunks for that particular file been received from the local meta store, the meta service will send that existing chunks of list back to the sync bit service. And that's how the code would look like. At this line of code, we'll have the new chunks of the file where the change has been detected, as well as the existing chunks saved for that particular file. So now let's discuss on the compare new chunks with the local existing metadata or the local existing chunks of that particular file. So in the if statement here, we'll compare the new chunks with the existing chunk just to identify the chunk where the change has been done, right? Because once we identify that particular chunk, we'll update that particular chunk. We'll only update that particular chunk to the blob storage as well as in the local meta store and the cloud meta store instead of updating the complete file to the blob. That's what we'll do once we identify that particular chunk where the change has been done. So let's look what's happening in the if statement. So this is the newly created chunk, and this is the existing chunk. So we can clearly see that the chunk ID or the block ID 001 is the block ID where we can clearly see there's a mismatch in the SHA-256. So if we compare the chunks one by one, and this is the chunk where we'll see there's a mismatch and condition will be false. And once we see that the condition is false, we'll move ahead to the else statement. And if the condition is false, we save data to blob. Let's see what's happening. So we move on to the else part where there's a mismatch in the existing chunk with the new chunk. And we call blob clients stage block method and save that particular chunk to the storage account or the blob storage. So this is the chunk where we have identified the change, and the blob will be replaced with that particular chunk, the new chunk where the change has been detected. And this is the sixth step. So let me recap what we have discussed in the step number 6. So we received the newly created chunk from the chunker service, and from the metadata service we received the existing chunk for that particular file where the change has been detected. We compared each chunk and we identified the chunk where the change has been done. And then to the blob storage, we have only updated that particular chunk where the change has been detected. Instead of uploading the complete file to the blob storage, we only uploaded or updated the chunk where the change has been detected. So let's move ahead and discuss on the next part, or the save chunk and save chunk to the metadata method calls. So let's move ahead and discuss on the save data to the local metadata using the metadata service. So this is the metadata service call where we are asking metadata service by calling save chunk method. Let's see what's happening inside that particular method. So we are calling the save chunk method of the metadata service, and metadata service is actually updating that particular chunk where the change has been detected. And this is the simple code to update the local metadata store. So this code is written just for reference only, and we have to make changes as per our requirement. So please take a reference from this code. That's it. So this is the eighth step. So there is one small typo in the previous discussion that I used 6 times 0 as the uh, chunk ID, but it is not the 6 times 0. It is 001, and I have also used 5 times 0 1. That is nothing but the chunk ID 002 and so on and so forth. So please keep that thing in mind that there was some typo during the discussion. So now let's move ahead and discuss on the the next method, save chunk to metadata. In this particular call, we are asking metadata service to update that particular chunk to the cloud metastore. So we'll ask metadata service to save data to cloud metadata where the change has been detected, that particular chunk. So this is the particular chunk where the change has been detected, and the metadata service will update that particular chunk to the cloud metastore when we call this particular method. And this is the sample implementation of that particular method. So again, just take this implementation or method as a reference only. And at the end, if we see that the step number 6, 8, and 9 are completed, where we see that the blob storage, local metastore, and the cloud metastore, all the databases are updated with the chunk where the change has been detected. So the phase two of the design discussion is also completed. Let me recap what we have discussed. So we divided the complete high level designing into two parts, the phase one and phase two. In the phase one, we discussed that there's a new file created inside the folder which was being uh, 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 watched by the watcher service. When we create a new file, the watcher service actually creates the chunk for that particular file, and then since the new file is created, there was no chunk available or chunk data available in the local and the cloud metastore, as well as there was no chunk saved or the blob saved in the blob storage. In the first phase, since there are no data saved for that particular file because a new file was created, we save those chunk details to the local and the cloud metastore, as well as we save those chunk or the blob to the blob storage. That's what we discussed in the phase one. In the phase two, we discussed since the file was saved inside the blob storage as well as in the local and cloud metastore, we make some changes to that existing file. And once we make that change, watcher service actually recalculate the chunk details for that particular file and send it to the sync service. Then further sync service ask meta service to send the existing metadata or the chunk details from the local metastore, and then sync service actually compare chunk by chunk compare the newly created chunk by chunk with the pre-existing saved chunk in the local metastore to identify the chunk where the change has been made. Once we identify the chunk where there is a mismatch in the SHA-256 hash, we actually get the chunk where the change has been made, and then we particularly update that particular chunk to the blob storage. Instead of uploading the complete blob, we actually update that particular chunk to the blob storage, as well as we update that particular chunk to the local and the cloud meta store with the help of meta service. This is what we covered in the phase 2. So now let's move ahead and discuss on the notification service. So notification service gets the notification whenever there's a change detected in the cloud metastore. We can also see two columns created in cloud metastore which are not present in the local metastore. So two columns are file and the device ID. So device ID is the device ID where we have notified and the changes are already synced on those devices. This is the step number 10 where the notification gets, it actually observe the changes made to the cloud metastore. And once there is any update happen to the cloud metastore, on the 11th step, it sends the notification to the machine where the change was not updated. That detail we can easily identify from the device ID. So all the devices are not present in the device ID and registered to get the notification if there is any change made to the files. Notification service identifies such machines and send the notification. If we just replace the client machine with the client machine B, and the complete process would work as it is, apart from some of the workflows. So notification service detects the change made to the cloud metastore, and then at the step number 2, it sends the notification to the meta service. So that meta service takes all the changes from the cloud metastore and save those changes to the local metastore. Before that, meta service actually takes all the updates from the blob storage and save that particular file change and sync the file on the local machine. In the step number 3.2, it actually updates the local meta store with the latest changes. So let me recap what has happened in the 3.1 and 3.2. Whenever a meta service gets a notification, it updates the file where the change has been made by other machines, and it takes that change from the blob storage and update that particular file to the local machine. As well as it also updates the local meta store with the latest changes. It actually pulls all the latest changes from the cloud meta store and save those changes to the local meta store to keep local meta store and cloud meta store with the latest changes and keep them in sync. So then once we make changes or meta service make that change to the local file, watcher service again gets a trigger. In the step number 5, watcher service sends that file path where the change has been detected. In the sixth step, sync bit service sends that path to the chunker service to start the chunking. In the seventh step, chunker service actually reads that particular file and create the chunks of that particular file. In the eighth step, chunker service sends those chunk details to the sync bit service, and then sync bit service actually asks meta service to send the pre-existing chunks of that particular file where the changes has been detected. So what happens next? There is no change detected because the file and the local meta store with those chunks detail for the file which has been updated by the meta service are already updated. So the file is also updated, and the local meta store, the chunk for that particular file, the chunks of that particular files are already updated in the local meta store. So there would not be any change detected by the sync bit service, and that's when there's no op in that scenario. So this is the complete system design of Dropbox or designing Google Drive. So I'll share the coding in the description of this video. So whatever code I was referring to, or the code I was showing during the discussion, I'll share the link for that particular code. So just take a reference from that code and make necessary changes as per your requirement. So hope you enjoyed the video. Thank you so much.